Hey, and welcome back. So we're going to look at the half-life of a second order reaction. So that's the amount of time it takes for half the reactants to be used up. So what makes it second order is that the rate law, right, the equation that predicts how fast it'll go, has a second power there above the A. And we saw last time, or actually several videos ago, that there is an integrated rate law for a second order reaction, and it looks something like so, I believe. Actually, I think it's minus there. So there we go. That looks good. And we can use that to calculate the half-life. So how are we going to do that? We're going to say at time equals 0, the concentration that you start with, right? We're just going to call A sub 0. And at the half-life, then the concentration at that time is equal to 1/2 of what you started with. And you should be able to go ahead and do the math here. And I'm not going to do it for you, but the half-life then is equal to 1 over K times by the original concentration. So one of the things to get out of this, actually the two of the things to get out with this, is that it's not constant. So the half-life is continually changing, and it's inversely proportional to the original concentration. So as the reaction goes along, so as the reaction proceeds, the concentration of A keeps going down. So basically, as the reaction proceeds, the half-life gets longer and longer and longer. So the less you have, the longer it takes for half the next material to go away. So let's go ahead and look at a reaction, right? So imagine you start off with something that's 1 mole per liter, and it goes down to 1/2 mole per liter. Maybe it takes 10 seconds. If it's a second order reaction, what it would mean is for the next half to go away, okay, it would take 20 seconds. And then for the next half to go away, it would take 40 seconds. And for the next half to go away, it would take 80 seconds. So essentially, it keeps getting longer and longer and longer because it's inversely proportional to the original concentration. So unlike a first order reaction where it would take the same amount of time every time, and a zero order reaction where it actually goes faster and faster and faster as time goes on, for a second order reaction, it takes longer and longer for the next half material to go away. And that's actually a way you can tell if something's second order or not.